Hello, ladies and gentlemen, and welcome back. My name is Abdel Nasser Ghazawi. I am from Jordan, and I am here to teach you about metal detectors and the science of metal detectors, how they work, how to build their circuits, and how to design them. And the first part of this tutorial, we are going to talk about the theory, then we will build some metal detectors ourselves. All right, so there's a lot to learn here. In the previous video, we talked about metal detectors, how they work, and I give you, let's say, a teaser about how the detection depth works out with a metal detector. All right. Now, in this video, I want to talk about the different types of metal detectors, right? But it seems like my whiteboard is not responding for some reason. All right, let's see. All right, let's keep this at 100% to make stuff work out easier for you. So now we have three basic types of metal detectors. All right. Now, any metal detector that exists out there in the world will fall into one of these three basic categories. The first one is called BFO. The second one is VLF, or sometimes called IB. And the third one is called PI. So what is BFO? BFO stands for beat frequency oscillator, right? Now this type of metal detectors it was the first type of metal detectors that was ever invented, right? So it's ancient, it's simple, it's work very well for its purpose, but the thing is, it's not sensitive. It can distinguish between ferrous and non-ferrous. So this is one of the advantages: ferrous versus non-ferrous, right? But it's no longer manufactured because it's not sensitive, and the depth at best can be maybe 30-35 centimeters with large coils. If you remember when we talked about large coils, so these beat frequencies are just like nowadays made as toys for kids, or just like for non-serious metal detectors out there, right? So this is no longer used, but we are going to start with this one because this will teach us a lot about the other types, learning about how a BFO works, how it operates, the calculations that go into BFO, and the circuitry will give us a greater understanding of metal detectors and will give us the experience that we need to build these other two types, right? Now, VLF, which stands for very low frequency, right? Or induction, all right? Let me just do this. Induction balance, all right? Now, this type of metal detectors is actually one of the most widely used metal detectors out there nowadays. It's very awesome. It have greater depth than BFO, but less than pi. But the thing is, VLF can give us a good idea of the type of the metal that exists under the soil. So it can tell us if it is first of all ferrous or non-ferrous with 100% accuracy, but it can also give us a good idea about what type of metal that exists. Is it gold? Is it silver? Is it iron? Etc. So this type of VLF metal detectors is very awesome, and we can build two circuits with when we want to build a VLF. We can build a VLF metal detector for its depth capability if we want to use it just to make a simple metal detector that's advanced, right? That's better than BFO, but at the same time, maybe we don't want to try to identify the type of the metal. So in that case, VLF circuit can be very simple. Actually, it can be so simple that is simpler than BFO. But if we want to distinguish the type of the metal, right? And especially if we want to know if it's ferrous or non-ferrous and such stuff, then the circuitry gets complicated. All right, it will be very complicated, and it's not for anyone to build. Let's say that. All right, but since it's have larger depth than BFO, and we learned a little bit about how we can maximize the depth of a metal detector, we can build a VLF to detect a coin at maybe from 30 to 40 centimeters. So this is very large depth for a coin, right? And for large stuff can go up to 1 meter, right? So we can do that. Now, for pulse induction, so pulse induction metal detectors. Now these have the superiority in depth, right? While they are very bad at discrimination. So discrimination basically means that if can we tell if this is a ferrous or non-ferrous that's under the soil, right? So pi is very bad, very poor at this capability. So the only two types that can distinguish between ferrous and non-ferrous are BFO and VLF. Now, I told you that BFO is old, obsolete, and not useful, but don't be mistaken. It can be very awesome in hunting coins, all right? So if you want to hunt coins and you want a simple circuit that works, then this one is the option to go with, right? So as I told you, pulse induction is very awesome. So pulse induction can go very deep under the ground. Actually, in theory, there's no limit to its depth. Now, of course, there's always limits to stuff in the real world, but the pulse induction can detect stuff maybe at 50 centimeters, can detect stuff at 2 meters, and so on. So it can go very deep under the ground. And in this tutorial, I will teach you how we can build all of them. So BFO, VLF, and pi, all right? But today's video is all about learning about these three basic types and what are the differences between them, their capabilities. So in the next video, I don't know exactly what's going to be about. I will definitely try to come up with something. As I said, I don't plan these videos. Whatever comes to my mind, I teach you. I try to make it. Each video I make, I try to make the next video a logical step from the one that's behind so that you can follow along and things are easy for you to follow. Now, I think I talk a lot. This video is about 8 minutes now. So that's all for this video. Thank you very much for watching. I will see you in the next one.